Well, welcome to Lesson 10 on solving and graphing inequalities. We're going to start this lesson with just a basic review of what an inequality is and what inequality symbols look like. And to start with, an inequality is just a mathematical statement that compares quantities that are not equal. So you will commonly see four different inequality symbols, and those are listed for you here. And what they mean, this first one on the left means greater than. The next one is greater than or equal to, less than, and less than or equal to. Some properties of inequalities are given in this table, and I know this is a lot of words to read, and basically I'll try to make this simple for you. If we start off with an inequality, A is less than B, this statement says we can add or subtract a number to both sides and it doesn't change the inequality. So you can see we just dropped in plus C and minus C, and the inequality holds true. Now here's the caution for you. The multiplication and division properties for inequality. If C is bigger than 0 and we have that same inequality, A is less than B. So basically if we have a positive number C, we can multiply both sides without changing the inequality. However, if C is negative and we multiply that inequality A less than B, that switches our inequality the other way. And then the transitive property says if you have two inequalities, A is less than B and then B is less than C, A has to be less than C. So some things you should know. There are an infinite number of solutions to any inequality. Solutions are shown on a number line, and you'll see that when we look at some examples. And then greater than and less than have an open circle on their endpoints. And if we have less than or equal to or greater than or equal to, those have closed circles for their endpoints. So let's take a look at solving some inequalities. This first example, we have m minus 4 is greater than or equal to 6. So we want to get m by itself. 4 is being subtracted, so the opposite is to add 4. And whatever we do to one side, we must do to the other. So we get m is greater than or equal to 10. Now because it's greater than or equal to, that's a closed dot on the endpoint 10. And the numbers that are greater than or equal to 10 are to the right. So there's an infinite number of solutions to the right of 10. It includes the endpoint 10. Over here on the left-hand side, we need to distribute the 3 through the parentheses. So I've done that for you here in this box. So we get 3t minus 12 greater than negative 6. Add 12 to both sides, and we get 3t greater than 6. Divide by 3, and we get t greater than 2. Now this does not include the endpoint. Remember, greater than or less than have an open circle, and we want all the numbers greater than or bigger than 2. So we label our endpoint, open dot, and then it's everything to the right. Here are 3 more examples. This would be a good time for you to pause the video. I'll give you the solutions when you come back. All right, hope you gave those a try. I hope you paused the video. Your learning is better if you try it on your own, see what you know. Excuse me. So when we distribute our 2 through the parentheses, we get what I have here. And then we're trying to get our variables together. We need to combine our like terms. So I added 2x to both sides. You could just as easily have subtracted 2x, but I don't like to deal with negative variables. So I added 2x. That gives me a negative 6 less than 4x plus 1. Then I subtracted 1 from both sides, and I got negative 7 over 4 is less than negative 7 is less than 4x, and then I divided by 4 on both sides, so I have x is greater than negative 7 over 4. So that is my solution. Then I graphed it on a number line. Just write it in there as negative 7/4 is fine. Now all the numbers that are greater than, I see I have an error in here, all the numbers that are greater than negative 7 over 4 are to the right. So let me edit this a little bit for you so that we have the right thing in here. So it's an open circle, because it's not included, so it's an open dot. All the ones that are greater than go to the right. So it should be everything to the right of negative 7/4, not including that endpoint. All right, so then the next example, distributing your 2 through the parentheses, combine like terms. on the right-hand side and then combine like terms by subtracting 3x, we get negative 3 is less than 8 because our x terms dropped out on both sides. So sometimes this will happen. If your variable drops out, keep going. Don't just stop. So now, is this a true statement or a false statement? Is negative 3 less than 8? Well, that is a true statement, so that means all solutions work. No matter what you put in here for x, you'll get a true statement. So that's the whole entire number line. All right, the one letter C, let's take a look at that one. Distributing the 4 through the parentheses, combining like terms, and then getting our variables together. Again, my variable drops out, so I ended up with 3 being less than or equal to negative 7. Is this a true statement? And this time this is a false statement, therefore there are no solutions. So if your variable drops out and you get a true statement, all solutions. If your variable drops out, false statement, no solution. Some more vocabulary words for you here. First of all, a compound inequality is two inequalities that have the word and or. So it's two inequalities together is called a compound inequality. A conjunction is an inequality that has the word and with it. A disjunction is an inequality that has or with it. So we're talking about compound inequalities here. Intersection is the solution where you have the conjunction of two inequalities, and the union is the solution set for disjunctions, or the union of the two inequalities. So here are some inequalities to take a look at. Now take a look at this first one. It has this inequality and this inequality. So we could solve that for x. We do have a true statement on the left-hand side. So when we have the word and, it's called a conjunction. So this inequality is an example of a conjunction. The solution is the stuff that they have in common, or the intersection of the two solution sets. So that one would have an intersection of sets. The second one has the word or, you will notice. So this is an example of a disjunction. The solution is the combination of the separate solutions, or the union of the solution sets. And the last one, I'm not solving these, I just want to give you examples here. This one is actually two inequalities together. You'll notice we have an inequality here and an inequality here. We can write that as 3x plus 2 being greater than or equal to 2 and 2 less than 14. There's an error right here. It should just say 2 less than 14, not less than or equal to. So those are examples of the vocabulary terms from the last slide. So now let's go ahead and solve some of these compound inequalities and graph our solution sets. So this first one, if we're solving, we're going to solve these independently. Solve 2x plus 1 greater than 9. I would subtract 1 from both sides and then divide by 2. So we get x is greater than 4. On the right-hand side, we subtract 1 from both sides and divide by 2. We get x is less than 7. So we need the intersection of these two solution sets. So any number that's bigger than 4 and less than 7 is a solution. So graph your two endpoints. Put the smaller number on the left, the bigger number on the right, just like you would in any kind of number line. And again, there's a little bit of a change I need to make here. These endpoints do not have equal to with them, so these should be open circles right here and the stuff in between. So that's a little bit of an edit there. Okay, so my solution set should actually be open and then align and then open on the end. Over on the right-hand side, we have 3n greater than or equal to 24. Dividing through by 3, we get n greater than or equal to 8. Solving on the right-hand side, we end up with n less than or equal to 4. So now these should be closed dots because they have equal to with them. So let's take a look at what we have. Now this is it's not the conjunction, it's the disjunction. So it's all the solutions that are bigger than 8, including 8, and all the solutions that are less than 4, including 4. So this is a correct solution. It's a closed dot left and a closed dot right, and all of those are solutions. So here's our last slide. It says a poll shows that 78% of voters plan to participate in a local election. This is a timely video for us this year. The margin of error for the poll is 3.5%, plus and minus 3.5. So it could be 3.5% above that or 3.5% below that. The problem says to write a compound inequality to represent the possible actual number of voters who plan to participate. So all you're going to do is you're going to say, well, maybe the number of voters, I called it V, it's going to be less than or equal to the 78 plus 3.5, but it's going to be greater than or equal to 78 minus 3.5. This will give us our low end point. This will give us our upper end point. So that is an example of the compound inequality that we would get representing the actual number of voters who plan to participate. And there's a little hint down here. Take a look at example 4 in your textbook and let me know if you have any questions on that, and I'll see you in class.